All right, so here we are again for the weekly recording of how to do the assignment. Yeah, so this part, you're just making the table. I haven't started on it yet, so trial 2, 5, trial 2, 0, 6, 2. All of these should have 4 sig figs because, well, the balance only measures to 2 decimal points. If you have 3, it's going to be incorrect, except it doesn't matter because at this point the chem department probably doesn't care. Okay, 5% standard solution, 3, 4. One, 4, 8. 3. 56.12. Zero. 60.8. Zero. Eight, 2. 17.40. 72.02. 6.23. 6.49. 76.84. 76.82. 72.9. 8.6. 81.8. 81. Seven. 6.33. So I use 2.66 grams of sucrose, 53.2. That's the standard solutions. I need to put down my beaker values. We can do with just take this, pop it into Excel. Along with that, we can switch this to 4.7 since that's the value we have in LabFlow now. Six point five four. 6.37. 56.9. 6.50. 56.77. Six and 50.78. We need mass of the standard solutions. One. Then do 60. Or we can do beef equals B4 minus B2, press F4 to set it absolute. And this down. Same thing here. C equals C4 minus C2. 4 minus D2. D4 minus D2. Equals F4 minus F2. G4 minus G2. F4 is then. H4 minus H2. Nope, not what I wanted. So we have B5 minus beaker. So this down, we get B6. It's the beaker. Do some hand calculations. 0.88 minus 4.93. 4.95. .86 minus 9.88. 7.8. 14.86 minus 9.88. This should go here. And this should go here. And then we know that this is 4.93. 19.69 minus 14.86. 4.83. 24.62 minus 19.69. 4.93. 4.77. 4.89. 5.3. 4.35. 4.99. Then what I think we can do is this was that. So what we can do is we can do equals C2 C5 minus C2 minus C. There we go. Equals G5 minus 2 minus D10. E2 minus E5. E5 minus 2. So E10. Do F equals F5 minus F2 minus F10. Was G5 minus G2 minus G10. Then equals H5 minus H2 minus H10. Okay, 4.93. 7. 4.89. 5.93. So that'll be 4.93, 4.95, 8, 4 point, where the cursor went, 4.83, 4.93, 7, 5.21, 5.3, 1, 4.99. Four point 89, 4.2, 4.3, 5.11, 5.10, 5.13, 9, 5.20, 0, 3.66, 5.85, 0.40, 0.29, 5.38, 5.29, 4.99, 4.95, 3.94, 5.00, 4.93, 8, 1.12, 5.11, 5, 5.9. Density 1, equals B16/5. Equals C16/5. Equals D16/5. Equals D16/5. Equals F16/5. G16/5. G17. H16/5. 0.986. 0.90. 996. 0.966. 0.986. Equals average standard deviation average six. Equals stdev dot to B26. Zero 985 standard deviation. So this is going to go to 99. 0.01. %, 0.954. 1.62. 1.24. Eight. Be at 3 sig figs, so 9. 2, 6. 10. Six. 1. 0. 0.198. 0. 0.03. 0.978. 2, 1.2, 1.2, 1.2, 1, 0.02. %, 1.3, 1.4, 1.4, 1.16, 0.732, 0.999. Standard deviation 1.0. Standard deviation is going to be 0.1. 20%. 1.07. 1.08. 1.06. 1.08. 6. 6, 8. 0.009. Zero point nine nine eight, 0.990, 0.988, 1.00, 0.986, 0.9924, and 0.206. Unknown, 1.01, 1.2, 2, 1, 4, 2, 0.009. 8, 5. Zero, zero. Zero dot 999. Two. And that 6, 7. My brain is not having it. Okay, so we're just needing the 5 retro solutions. We don't need this. Density. Leader. Solution concentration. Variance. Sucrose. Concentration. Documents. Yes. Slope from linear regression, that is going to be 0.338. Linear regression is just our trend line. Then 9.79 for our y-intercept. Okay. So now we have that here. Do same thing, but this time we're going to do 0.338 J1 equals 0.338 J1 plus 0.979. Let's see what that gives us. Let me just drag this to the right. Five. Five. 3. Six. So we got 979. 6. 1. So at this point, we're getting into the tricky stuff that lots of people are having questions over. So it's definitely something to pay attention to. 5, our average density, 0.995. 0. And 1. 0.999. 1.7. So our residual here equals J2 minus J4. Zero dot 0.006, 0.004, 0, 1.3, 0.02. Zero 0.031. Let's see. I could do 20% Q test, and 20% the closest neighbor is going to be 0.06. So do .020 minus .006 all over .020. Okay, yeah, so for your calibration curve, just use the averages.
Wait, okay, I have a question.
Mhm.
Wait, can you hear me?
Yes,
Okay. Can I ask the question?
yeah.
Okay, so for the graph, do we use the average from the table of the density of the standard solutions?
Yeah.
Okay, so that's what it just feels like my average is like kind of high compared to everybody else.
What do you mean?
Like hang on. Okay, so I'll start my video. Hang on. Okay, so like here, these are my averages. So you're saying like the graph has these averages on the y-axis?
I think you got those averages because from what looks like, it looks like you didn't subtract the like preceding mass from each one. So you remember how last lab we had to measure like the aliquots of each sample and subtract?
Yeah, I did that.
It doesn't look like you did though.
What? The mass of the beak? Are you talking about like the mass of the beak?
This is a big thing.
Wait.
You push it like this.
Yeah, are you talking about the mass of the beaker minus the like this?
Yeah, go back down to
what?
keep going down to the next table. All right, right there. See how your trials keep increasing?
Yeah.
If I share my screen right now. Then, let's see, where is it? They should all be around the same value like this.
Mass of the standard solutions. Well, it's still our. Wait, what? Wait. No, because how is that wrong? Because I subtracted these values from the mass of the beaker.
From the mass of the beaker.
Yeah. like to get these.
Yeah, but then you also have to subtract the preceding mass. That way you can get each individual mass by itself.
The preceding mass of what?
So take like, let's look at trial 3 for the mass of distilled water. You'd have to subtract the mass of trial 2 in order to get how much you added for trial 3.
Oh my God, you're right. Oh my God. That's great. Thank you. I'm actually dumb. So for like, so for trial 2 for the mass of distilled water, the 8.773 should be subtracted by the 3.786 is what you're saying to get trial 2.
And say that again.
So for this one, for trial 2, the mass of this distilled water,
Yeah.
8.773 should be subtracted by 3.786 to get trial 2.
Yeah.
Oh my God, I just wasted all my time. I give up. I literally give up. Thank you so much.
Carter,
Hmm?
can I ask you to look at something for my my lab flow?
Yeah, sure.
Okay. So we put in our data last night, and like I had asked a couple of times in the group chat to calculate how to calculate this, because I didn't remember, because I didn't know, because I think it's like mass of the solute divided by mass of the solute times mass of the solution, right? To calculate the approximate mass for sucrose.
Use the mass of sucrose and the mass of the total solution.
You said it should be mass of sucrose over mass of total solution.
Yeah,
Okay.
which should give you what you have, right?
I did mass of sucrose over mass of sucrose plus the mass of the solution.
Okay, yeah, you should already just have the normal mass of the solution.
Our solution was 50 grams. And then, so do I just do this times the 50 grams or divided by the 50 grams?
With mass of sucrose, use 2.6. Mass of distilled water used to make the 5% standard solution.
So I use those two numbers.
So add 2.6 to 2.7.972 and then. So yeah, shut up, Google. So do 2.6 over 2.6 plus 27.972, but that should give you what you have.
Hold on.
Are you sure you measured the mass of the distilled water, right?
No, I'm not sure. Because
It should be around 50.
that's what I thought. And like when I did this calculation, I did it by 50.
Yeah. Where did you get that value from?
I think what I did was I think I subtracted because I have wait, hold on. Okay, I can show you my data. So this is what we have, and then because I wasn't sure what measurements to use for this, so I just did the 50, and then
Well, you did what?
I just took the 50 grams over this 2.6. I didn't know what else.
So what you're telling me is that neither you or your partner recorded how much water you used for the solution.
No, we used 30 milliliters for the solution.
You're supposed to use 50.
Mm.
Because since you use 30 milliliters, instead of having a 0.0 or instead of having a 5% standard solution, you have a 10% standard solution.
So what should I do for like the rest of the data then?
You could probably request, or can you even say that you took it online? Go back to the top.
I think, well, I'm not sure because I haven't redone like did the attempt again. I just did this last night.
So go back down to where it said, why are all of those incorrect?
That's what we were trying to figure out too. We had no idea. And it's saying like all of this, but I don't even know what it's talking about for a previous trial.
Okay, so the previous trial would just be the mass of the beaker.
And like the way that I got these numbers are from like this row that's highlighted in gray.
Go ahead and click on cell B9. What's the formula you're using for that? B3, B2, okay. And I'm guessing that entire row is for the yeah, that entire row is for the 5 milliliter solution, right?
Yes. And then the percents go up horizontally.
Wait, go ahead. Well, actually, I'm guessing you probably just typed or manually typed in B3 minus B2 for each cell.
Actually, so our lab AI, he typed in the formula and did this math while we were working in the lab. So, but yeah.
Click on C9. C3 minus C2. So that's where it's wrong.
So what is it supposed to be?
Instead of C2 because you have your wait. Okay, never mind. And go back to your table in LabFlow. 5.065, 5.055. Okay, go back to the Excel. I would say try. Well, it only goes to 2 decimal places. So if we're following sig fig rules, then that should be 5.07, not 5.06. For that like first measurement in B9. And the same would
I
go
should
for,
round it differently.
yeah, the same would go for all of those original values where they would only have 2 decimal places.
Well, I just added 0 so that everything is 3 decimal places to the rest of them. Because like Excel, you know how Excel takes them out.
And that's fine, but 0.6 or the 5.065 should be 5.07, only be at 2 decimal places. So that might be what's wrong.
So, and then like for this stuff, like if we have like our average and standard deviations, right? How is this stuff messed up? And then like it's saying using this in the 5 milliliters in sulfur density. And these numbers came from this down here.
Okay, what's the formula in cell B33? Okay. Go back to your lab flow table. But yeah, these are all densities. How did you get that low of a density? Because you should just enter what you have in that Excel table to the table right here.
From this table right here.
Yeah.
Okay. And then my last question is about our linear regression line.
Mhm.
So we have, this is our equation right here and like our
Yeah.
R squared. But then when we go to LabFlow and like when I typed it in, it's wrong. So do I need to write
Wait,
it?
go back to your linear regression.
Okay.
Where are the values that you used for that?
It's right here.
Okay, go ahead and scroll down to your original value table.
We got these numbers from this right here.
Let's check something. Okay. I mean, I think a lot of it could just be a sig fig problem. So if we go back down to your density table. Yeah, you're going between 3 and 5 sig figs.
Nothing is rounded in these tables. Like, and then,
Do you have a table somewhere that is rounded?
no, because this is just because he used the Excel to calculate all of this. And we didn't change anything. This is just how Excel did it. And then when I typed it into LabFlow, I like rounded everything to, I believe it was either 3 or 4 sig figs. And that's how I got all those like this. But I don't even see.
Well, somehow you managed to, wait, yeah, go back. Those should all be around 1. Where did you even get those values from?
It's this stuff divided by 5.
Okay, yeah, but go back to LabFlow.
Ignore this because I think he went back in and changed the calculation for this. Because we did this, we went through and then I put all this stuff in. But if I do put these numbers in, will it change this? Or should I change these measurements too when I put the other numbers in?
Yeah.
Okay. And then, so you said, and then for the slope and linear regression, you said just check the sig figs in?
Concentration of density, wait. Go back to your, I think it was right, but got to be sure. So go back to your linear regression. So that's fine. I'm not sure why that would be wrong then.
Like, do I need to have like an X or something on the end of it?
Nope.
And like, I don't even know, use data plot for concentration X and that. Like,
Wait, go back up to your average densities. So basically what it's doing is you have your average densities right there. It's taking those values and using them to like calculate it down there. So since you have all of this wrong, then that's going to be wrong. And it's just going to keep cascading through the assignment.
all right. That makes sense. And then just for these using the proper trend line. So when I do go back through, I'm using the linear regression equation that I got from my graph and I plugged the numbers into that for the X, right? and solve for y to determine this stuff?
Wait, no, you should plug in for y and solve for x to determine the percent in sucrose by mass. So you would
Okay.
plug the density into the trend line.
And I do the same for the Kool-Aid mass too. I use the
Easy.
average mass.
X should not be equal to the average density of Kool-Aid. So whoever wrote the assignment is wrong. Same thing for the next question. But yeah, so solve for X. So you plug the density in for Y, and then solve for X.
Okay. I believe that is all my questions. So I appreciate the help.
You got one.
Huh?
Wait, Tasneem, did you get like 1,734 or 1,734,000, also known as 1,734 million?
No,
Oh.
I got 1,000, but I did it again and I got 127.9, 12700.
So that should,
So should that be fine?
experimental minus literature.
I did it again. So the one I sent you is the first one.
Yeah, that should be fine.
Okay. And I have another question. How do you solve the T-stat and the T-critical?
You can just use Excel for that.
Yeah, it's not loading. Can you show me how you do it?
I don't think I even have it downloaded. Hang on. Hmm. Data. File menu, top left corner, options button. Edits. What is? Okay. There we go. Okay, here, go ahead and share your screen so I can see like the Excel worksheet.
Okay. I'm on my phone right now. Can I just, I'm
Yeah.
gonna start the video. Okay, so that's my Excel.
Okay, so click on data. And then Wait, are you using Excel Online?
No, I went through my one.iu and then I clicked on the Excel and then I went here.
Okay, so that is Excel Online. What type of computer do you have?
Chromebook, HP.
Okay,
So, and we have another laptop and it won't add.
try logging into your IU Anywhere.
I'm already logged in. I have mine.
Yeah, but like I'm talking IU Anywhere. Basically, it lets you just open up a virtual desktop. So then you can use the desktop version of Excel.
Okay. So my friend has that, but it won't let her add.
Do the add-in thing for the data analysis.
Yeah, do the adding thing for the data analysis.
Does she have it up right now?
Yeah.
Let me see it.
Just says like it's adding.
Try it again.
I did like 3 times.
She did like 3 times.
Then. Is that also a Chromebook?
No, it's a Microsoft.
Oh, then you should just be able to download Excel.
Yeah, I have that. It won't let me add the data analysis toolpack thing.
I would say save the file and then close out of Excel. And just relaunch it.
All right.
You get it.
Were you able to get into IU anywhere?
Wait, what's that? I've never been to it. Are you what?
Anywhere.
Are you anywhere?
Yeah.
Yeah, so what do I do now? Detect receiver?
So
I can't open this page. That's what it told me. Oh, never mind. I got it. So where do I go? Do I go to apps?
I don't know. It's been a while since I was in there. Go ahead and share your screen or start a video with your phone. Yeah, go to Excel.
Okay, I think it worked. Okay. Yeah. So my friend got it for hers.
All right.
Yeah. All right, thank you.
And we're back to working on this. You need to solve for y, which means that you're going to do equals G27 minus 0.979. Put this in parentheses, that way we don't have any mathematical fuck ups. Then we divide it by 0.338. So have that, we use our trend line. And we can go back to LabFlow. Where this is going to be 0.36. Then our unknown is going to be 0.12, so 12.72%.
Hi.
Mm-hmm.
Okay, so I got for my slope, it said I got both of my slopes wrong, but it said I got my y-intercept right. And I don't know why. And for my slope, I got 0.3978. So I feel like it should be right if my y-intercept is right too, right?
Go ahead and share your screen. So go back up. Okay, go to your slope. Like your first
So
slope.
that it right?
Okay, can I see your calibration curve? Let's see. Some reason I can't see the Excel, so I'm just gonna options. Yeah, for some reason I can't see your Excel.
You can't see it.
Mm-mm. Go ahead and stop your screen share and then try it and start it back up.
Okay. You see it now?
Yeah. Wait, why? Okay, where's the calibration curves? Densities, those are on the left, right?
Yeah, it's this stuff.
Go ahead and set all of the Y values to 3 sig figs and see what happens.
Is that all of them?
Yeah.
To what number?
To 3 sig figs.
6.
No, 3 sig figs. So
3 sig figs. Okay.
yeah.
You said 3. I'm sorry.
That second one, or that third one, and that fourth one both have 4.
So, but if I changed it like that, wouldn't I have to do all of the calculations over again?
Yeah.
But my next question is for this stuff. Damn. Okay, so like this, I don't understand how I could have got the first and the last part right and all the middle wrong.
Go ahead
And you
and
did it for
reset
my
your
friend
screen
like that
share
too.
again.
So, can you see?
Let's see.
And
Expected
it did the
density.
same thing for my friend too, but we didn't have the same data. He had a different partner, but he had the same problem. And I like redid everything.
So you went through and plugged the concentrations in for X and everything, right?
Right. And I double checked and it all still checked out. Now the last one in the residual one, I just forgot to add a 0. But the middle column, I'm at a loss for how that could be wrong.
Go back into Excel and then try the values again, see how much they differ from the ones in LabFlow.
Set to what?
So find the expected values again, and then see how much they differ from the values in LabFlow.
Okay, but just do it with the 3 sig fig, like right here, or still do
Yeah.
it with.
No, do
Okay.
it with a 3 sig figs. Here, just click in B31, so that cell.
Mhm.
And then type $, 0.404. Wait, where's the 0.994? Oh yeah. Change that 0.994 to B29.
And then just put parentheses.
Yep. Yeah. Okay, then click back on, yeah, just drag it out to the right.
And then compare it to the one that's in LabFlow. Okay. This is for the expected, right?
Yeah.
Well, they're all, I mean, they're all still ones, but the second number behind, or the first number behind the decimal, they all have zeros for the stuff that I already had. But in the Excel, they're all 3s and 4s behind the 1.
How many attempts do you have left?
1.
1?
Yeah, it said I only had 2. So I don't know if that was different for other people.
Wait, no, this is for the expected. So go back into B31. Change B29 to B28.
And then drag it out.
Yeah.
Okay.
Okay.
That's pretty similar. I think.
From what I understand, a lot of people are getting like the whole slope thing wrong. So I think that if there isn't any calculation issue, then it's got to be a chemistry department issue.
Okay, because in the Piazza stuff, I asked a question, and I asked about the slope thing, and then I asked about how I was getting answers wrong, but other answers right, even though the answers that are wrong have to be right because I got the answer that I used for that right. So I asked her if it was a laughable error, and I hope she sees it or someone sees it, because I feel like this is happening to a lot of people. And I only have one more attempt, so I don't know what to do.
Let's see. I'm gonna finish up my assignment and submit it and see if I get anything wrong.
Okay.
That way we can prove whether or not it actually is like a chemistry department error.
Mhm.
Okay. Average density, so that's gonna be 16 over 236 times density we had here, which was 9924. Zero point zero six 683%. Then 6.8. 3.96 minus 6.83 over 6.83. 42.02. T-test, data for the Kool-Aid and onions samples. How this Okay, let's see. Okay, so for this, it also said I got the slope wrong. Both times. So I definitely think it's gonna be a chemistry department problem.
Okay, cool. I mean, not cool.
And if
but
they don't
cool.
answer us, all we need to do is just simply start mixing all the chemicals in the storeroom together with no idea what they are.
Okay, well, that was the only question I had. So, do you think I should just my lab is on Wednesday, so I don't really have to turn this in tonight, but I'd rather get the pre-lab and all that done tonight. So, do you think I should just leave it until maybe
Let's
more
check
questions on
something.
Piazza?
So it is this. Okay, so on my understanding of it, here, let's read through this grading thing together, shall we? This course will be discussed. Okay, for each assignment, you'll be given guidelines or detailed rubric with the specifications needed to achieve to complete the assignment successfully. These specifications will be related to the course learning objectives, and the learning objectives for individual assignments. Meeting the specifications will indicate that you have demonstrated understanding and application of learning objectives. Okay. So choose to complete whichever grade bundle best corresponds. The satisfactory designation means that, so a bundle nowhere does it say that we need to have the pre-lab and the post-lab assignments complete all the way through.
What do you mean by that?
So what I'm looking at right here, right, is going to determine your final course in the grade.
Right?
So if you want an A, you need the math skills and Excel check-in, formal lab report and the preparation, finding and evaluating scientific information.
Right.
So Then we have the pre-lab for the lab. So that's all the lab flow stuff and the post-lab. It doesn't say that they need to be like satisfactory or something. So that means as long as you get a 50% on the lab flow, you'll probably be fine.
I thought that, well, I did read one time that for like a satisfactory for the pre-lab were 70% and those post-labs are 80%. But I just, the fact that they don't get graded all the way fast either, because you have like pending stuff still, doesn't help.
Let's see, is it
Because if
somewhere
I
in
could
here?
calculate it already, I would just leave it alone. Maybe it was my own.
So it's not in there. It's in this.
Okay, go back to the bundle thing.
Mhm.
It's all the way at the bottom and it says assignment types.
Okay, scores greater than 80%. You want 2 attempts for the assignment to date. I'm about to throw hands with somebody in a lab coat. Okay. Yeah, because if they keep having it mess up like this.
What you said?
If they keep having their assignments mess up like this, where people are just where everybody is getting like one thing wrong.
I'm sorry, my computer went out. What'd you say?
I'm just saying that the class is basically rigged.
Very much so. And a 2 credit course should never be this difficult. Ever.
Because
I feel like
in
it needs
order to get an
change.
A, right? A's, or they're basically defining that people who get A's are people who are going into pre-med.
Are you pre-med?
No.
I am. But you're better at this than me.
So
I feel like she needs to lower the percent for satisfactory. If you're gonna make the post lab
hang on,
70%,
let's see.
at least make it 75%.
Where is it? Lab skills, post lab. Nope, nope, nope. scores greater than 80%. Group scores greater than 70%. So, a lot of complicated math. But less complicated than the math takes to mix bleach and ammonia together inside the ventilation shaft of the chemistry building. Satisfactory designations means the student has achieved the learning objectives and met the specifications for assignment. Under that statement right there, I would think if people can go through, do the lab, get the data, and then plug it in, and it all follows the same trend, then it should be satisfactory. Not
Yes.
left up to some AI grading program where it's gonna mark half of the things wrong.
I feel like they need to go through that themselves, because that's why I was feeling such a pickle. Because I know my stuff is right. It may not be right to a T, but I know it's generally right. So I don't understand how I'm getting.
Who do we contact here?
Why don't you just email Spencer Lee?
Oh, we can email Spencer, but we also should probably contact like student affairs, get them on our side.
Yeah.
That way we
fine.
can just open up a whole case and change this course.
Yeah, because it sounded easy at first the way she was saying it, but all this. No. But my meeting is starting for in 3 minutes. But could you let me know what you figure out or if you say anything?
Yeah.
Okay, thank you so much for your help, though.
Okay, and if I share here. Okay, so right here, here's our calibration curve. And most of the values are pretty much by.
They're pretty close. Go ahead and take 0.05.
Okay. Is it the only one we're gonna do?
I mean, you just have to choose one.
Just choose one.
Yeah, so we'll take the 0.05
Okay.
and then take the residual of that.
So I would subtract the value for 0.05 with the value of 0.0
Mm-hmm.
and then divide that by the range. So the value of this and this.
Yeah.
And so if it's less than 0.710, then it's not an outlier.
Yeah.
And so that would mean I have no outliers at all.
Yeah.
And that's it.
Mm-hmm.
Okay. So but for on the lab flow, it has a whole column where it says put the residuals. Is
Yeah.
that just I'm sorry, is that just the values that I get by subtracting it?
Yeah.
So the values that I ranked is what I'll put in that column.
Yeah.
And then so for the questions below, when it says pick a suspected outlier, I just put 5%.
Yeah.
And then the value that I calculate by using the equation is what I would put there.
Yeah.
All right, bro. Thank you.
Yep.
They made it so confusing, but you simplified it.
I'm about to open a case against Spencer and just lay into her grading thing
Yeah,
because I just got like half of it wrong, even though I did everything right.
Yeah, like that's the same with us last night. Like we submitted it and like
Yeah,
half of it was wrong.
I saw your partner earlier.
Yeah. Oh, you talked to Candace already?
Yeah.
Oh, okay. Oh, yeah. Thanks. If I have any subsequent questions, I'll either text in the group me or see if you're still on the Zoom.
Hello.
Hello.
I got a question real quick on like what's it called? So like my Excel, I think
Mhm.
my densities is like I don't know what's wrong with it. This is how I'm getting my graph. I can share my screen if that's all right.
Yeah.
So yeah, this is how my graph looks like, and I don't know what to do.
I think, or are you trying to get your trend line, right?
No, but I'm saying like this is how it actually look like. Is it supposed to look like this, or is it supposed to be a linear graph, like straight line? with the
Well,
point?
the way your densities are, that's how it's gonna end up.
Yeah. And so like for the linear and the equation, is it the trend line, right?
Mm-hmm.
And
Get them, click on more options. There.
And so also another question, where are we supposed to get our expected density from?
Your expected density is what value you're gonna get when you plug in the like percentage for X.
So you just plug in like 0.005 into the X value. Should I just plug in, okay, like for the first one, I just plug in 0 and I get that value, and then for 5%, it'll be 0.05 into the X.
Yeah.
Okay, yeah, that makes sense. Right. Can I still be in here if I have another questions I can ask you?
Yeah.
Thank you.